So this is unit circle, and my kids have already memorized the unit circle quite well. About half of them have memorized it, so I'm going to approach this as though my students have done this. But this is the key concept. Unit circle has the equation x squared plus y squared equals 1, center 0, 0, radius 1, and it's called the unit circle. And we've already derived all of this stuff in class another day, and most of them are well on their way to memorizing it. So the cool thing about the unit circle is the following, that on the unit circle, and for those of you that have memorized already, this is when that stuff kicks in, sine is the y-coordinate over the radius of the unit circle. Now on the unit circle, the radius is 1. So on the unit circle, sine of theta is just the y-coordinate. Anyways, cosine is x over the radius. And our very first trig identity, because I want you guys to know this, because I am intending on doing some trig identities, is that tangent is sine of theta over cosine of theta, which sine would be y over r, divided by cosine, which is x over r, and then the r's cancel, and we're left with y over x. So that's how tangent comes from. And the reciprocals, of course, cosecant being the reciprocal of sine, it would be r over y. Secant being the reciprocal of cosine would be r over x, and cotangent would be the reciprocal of tangent, so it would be x over y. Anyways, here's your little meme. It's not even somewhere I already have a tangent because sine over cosine is tangent, and a sine gerene over a cosine gerene is a tangerine. Anyways, remember that one. All right, evaluate 6 trig ratios for the quadrantal angle 0 degrees. So what's a quadrantal angle? Is an angle that's stuck between quadrants, i.e. it lies on an axis. So it's either going to be on the x-axis or the y-axis. Now, by the way, before we start, 0 degrees is 0 pi rads. These notes are for an older group that have not memorized the unit circle yet, so you guys should be good on that. So we're supposed to find everything about the 6 trig ratios for the quadrantal angle of 0 degrees, which is right here. And I'm interested in that ordered pair. So we're going to find the sine of 0 degrees by doing y over r, and the y-coordinate here is 0, and the radius of the unit circle, this is a unit circle, the radius is 1. So we get 0 over 1, which is 0. Cosine of 0 degrees, we're going to do x over r. And the x-coordinate is 1, and the radius of the circle is 1, so we get 1. The tangent of 0 degrees, we're going to do y over x. So the y-coordinate is 0, the x-coordinate is 1, and that's still 0, just kind of like sine was. And it gets kind of interesting when we talk about the reciprocals, right? So the cosecant of this thing would be r over y. So the radius is 1. At the y-coordinate is 0, and we get undefined. Some kids forget about the whole 0. I don't know why I'm putting thetas in there. I must be tired. Secant's going to be r over x. The radius is 1. The x-coordinate is 1. It's 1. And by the way, these are reciprocals. The reciprocal of 0 is undefined. You cannot flip 0. The reciprocal of 1 is still 1. And then we have the tangent of 0 degrees, which is going to be x over y. So it's going to be 1 over 0, which again is undefined. And that's our big quadrantal angles. Now the next slide's got a mixture of quadrantals and things that aren't quadrantals. It's mostly quadrantal. 3 pi over 2 is going to be a quadrantal angle. This is where the unit circle shines. The unit circle shines on quadrantal angles. There's other ways of finding trig ratios, but for quadrantal angles, it's a circular approach all day long, or a technology approach. But in here right now, it's a circular approach because it's right here. It lies on the y-axis. I'm asking you to find the sine. The sine ratio is y over r. The y value is -1. The radius is 1. So the sine of 3 pi over 2 must be -1. Cosine of 6 pi. Now, 6 pi would travel around the circle 3 times. Now, what you can do is you can think about your idea of coterminal angles, and you can plus or minus twice pi. So if I take away 2 pi, I'm at 4 pi. If I take away 2 pi again, I'm at 2 pi. And if I take away 2 pi again, I'm at no pi. So here's where I am. I'm right there. And again, cosine is x over the radius. It is a unit circle, so the radius is 1, and the x value there is 1. We've already done this on the previous slide, but it ends up being 1. Cosecant 7 pi over 4 is going to be right here. Now, in addition to the cosecant ratio being hypotenuse over opposite, the cosecant ratio is also the r value, the radius of the circle, over y. And the unit circle has a radius of 1, and the y coordinate here is negative root 2 over 2. So we're going to have to do some old school math. This is going to be 1 times negative 2 over root 2, which is negative 2 over root 2. And then we're going to clean it up by multiplying the numerator and denominator by a root 2 over root 2. We're going to get negative 2 root 2 over 2, which is just negative root 2. Fun stuff, isn't it? All right, the cotangent of 3 pi, and again, use your idea of coterminality by taking away 2 pi, and now you're just thinking about the cotangent of pi, which is right here. The cotangent ratio is x over y, and the x coordinate there is negative 1, the y value is 0, and anything divided by 0 in mathematics is undefined. Tangent of 3 pi, again, we'll just do the same trick. This becomes the tangent of pi because of coterminality. So same place, tangent's y over x, so this is going to be 0 over negative 1, which is just 0. Moving forward, it's not a hard lesson, is it? Using the unit circle, evaluate the 6 trig ratio, 6 trig functions for 27 pi over 4. So again, I'm going to use the idea of coterminality. I'm going to take 27 pi over 4. And I'm going to subtract a bunch of 2 pi's, okay? That's what I'm going to do. I'm going to take away a whole bunch of 2 pi's. I would love to do this old school. I probably should be doing it old school, but I just don't feel like it. I don't have a whole lot of time. Now I'm stopping right here, because that is 3 pi over 4. So I'm going to work with 3 pi over 4. I'm going to say I'm doing 27 pi over 4, but I'm going to work with 3 pi over 4. So the sine of 27 pi over 4 is the same as the sine of 3 pi over 4, which is right here. There she is. And again, it is y over r, so it's going to be a positive root 2 over 2 over 1, which is just root 2 over 2. You know, on the unit circle, it's always just the x or y coordinate. Cosine 27 pi over 4. I'm going to look at x, which is negative root 2 over 2. Technically, I was looking at x over r. Don't be that kid who thinks that isn't a problem. The tangent of 27 pi over 4. I'm going to do y over x. So this is going to be a positive root 2 over 2 divided by a negative root 2 over 2. And this is something divided by its negative self, so it's negative 1. Moving on to the cosecant, the reciprocal of sine. So I can just flip this. It's really up to you, or I can do 1 over root 2 over 2. Which would be 1 times 2 over root 2, which is 2 over root 2, multiply top and bottom by root 2, and I get 2 root 2 over 2, which is just a positive root 2. Next up is going to be secant. Now notice that these guys were the same, except for signs, so these guys are going to be the same except for signs, negative root 2. And lastly, we have the cotangent, which is x over y, and it's going to be the same as this, except you're going to have the negative root 2 over 2 on the top and the positive root 2 over 2 on the bottom, and it's still going to be negative 1. All right, not a whole lot left now, is there? Ain't nothing about this too hard. Theta's terminal side intersects the unit circle at the following coordinates: negative 1/3, 2 root 2 over 3. State which quadrant the angle lies in and evaluate the 6 trig ratios for this angle. this guy happens back some and up some. So this is definitely a quadrant 2 angle. All right. Now speaking of that, ASTC, I know that sine and cosecant are positive, and all the others are negative. Now, by the way, this is on the unit circle, so the radius is 1. And again, I'm telling you, that guy's negative, that guy's negative, negative, negative. So you already know some answer choices, or at least I know some results. Anywho, since it's on the unit circle, the radius is 1, the sine is just going to be y over 1. So it's going to be 2 root 2 over 3 over a 1, which is just 2 root 2 over 3. Cosine is going to be x over 1, so it's just going to be negative 1/3. Tangent, going to have to work for. Tangent is going to be negative y over x in this case. So 2 root 2 over 3 divided by negative 1/3. The 3's cancel, and sure enough, there's my negative symbol. I get negative 2 root 2. Cosecant's going to make you work for it, okay? I probably need to erase some paper, erase here so I can have some room. Cosecant is going to be r over y, so I'm going to have 1 over 2 root 2 over 3. Now flipping this, I get 1 times 3 over 2 root 2. Cleaning this up, I get 3 root 2 over 2 times 2, which is 4. I told you cosecant is going to make you work for it a little bit. Secant's going to be easy. Secant is this guy over, it's 1 over this guy. It's the reciprocal, it's negative 3. And then we have cotangent, which is going to be x over y. And it's going to make us work for it too. It is. Because it's going to be negative 1/3 over 2 root 2 over 3. 3's cancel. I get negative 1 over 2 root 2. I clean it up with a root 2 and a root 2. And I get root 2 over 4. That made me work for it. Last slide. No. Which is a non-unit circle. This is not unit circle. Okay? Now, let me go back to the notes on the circle. And even though I'm talking about the unit circle here, here's another equation. It says r squared is x squared plus y squared. And that comes from this equation. The radius is 1, the center's at 0, 0. Okay? X squared plus y squared equals, if the radius is 1, then that's also r squared. It just comes from the equation for the circles. Anywho, I need to know the radius. The reason I need to know the radius is, well, tangent I don't have to have it, but tangent's y over x. But secant is r over x. So I have to have the radius. So, r squared is, let me write this down again, r squared is x squared plus y squared. So r squared is going to be x, which is negative 4 squared, plus y, 7 squared. So r squared is going to be 16 plus 49. And 16 and 49 add to what? 65. R squared is 65, which means that r is the root of 65. I'm going to go to town with it, all right? Tangent's y over x, that's the easy one. That's 7 over negative 4, which is negative 7/4. Now for secant, I'm going to have root 65 over the x value of negative 4. And again, negative symbols belong in the numerator or out front of the fraction, never in the bottom. And these are not hard. I think I do need to add a little bit for these for the in-class notes, but I don't think you'll have too much of a problem with them. We'll find out, right? Anyways, there is 13.3, because I'm going to change the title of the notes, the circular approach.